Alright folks, welcome to video lesson 5-1, our first lesson on trigonometric identities. Alrighty, let's go. Just to remind yourselves, when we talk about trigonometric functions, we're talking about ratios. We're talking about the ratios of the sides of a triangle. You remember SO, CA, TOA. Sine is, if this is my theta right here, sine is always going to be opposite side over hypotenuse. Cosine is the adjacent side over the hypotenuse. And tangent, of course, is the opposite side over the adjacent side. Okay, so there are our three trigonometric functions. These first few identities you already know. The first six are the reciprocal identities, which you know. Okay, so please make sure you take a minute and get these down into your notes. But you already know these from what we did in chapter 4. Sine is the reciprocal of cosecant, cosine is the reciprocal of secant, and tangent is the reciprocal of cotan, etc. Okay, so take a minute, stop the tape, and write these down. Okay, let's move on. Your quotient identities you also know from when we were graphing tangent and cotan. Tan is equal to sine over cosine, and cotan is the reciprocal of that, of course, cosine over sine. Put those down into your notes and stop the tape if you need to. Let's go. All right, the Pythagorean identities. On the unit circle, if this is my theta and this is on the unit circle, my hypotenuse is 1. We know if this is a right triangle, x squared plus y squared is equal to 1 squared. So therefore, we know that x is equal to cosine, y is equal to sine, and 1 squared is just 1. There's our Pythagorean identity. Cosine squared plus sine squared is 1, or if you want, sine squared plus cosine squared is equal to 1. Several times now in class, we've derived the other two versions of this. Tan squared plus 1 is equal to secant squared, and cotan squared plus 1 is equal to cosecant squared. But just remember that these can also be written 1 minus sine squared is equal to cosine squared, or 1 minus cos squared is equal to sine squared. Secant, this can be written secant squared minus 1 is equal to tan squared, or secant squared minus tan squared is equal to 1. Lastly, this can also be written cosecant squared minus 1 is equal to cotan squared, or if you prefer, cosecant squared minus cotan squared is equal to 1. Okay, so those are the 6 other versions of these Pythagorean identities. Stop the tape if you need to and get these down into your notes. All right. All right, the cofunction identities. These are pretty cool. Okay, if I take a triangle and I put my theta right here in red, we do realize that this angle right here in blue is going to be the complement of theta, right? Where 90 minus theta. Okay, I'm just going to label my sides. We'll still label the hypotenuse h, but from the original theta in red, we'll label the opposite side a, and we'll label the adjacent side b. Okay, now let's notice here, in red, the sine of theta is equal to the opposite, which is a, over the hypotenuse, which is h. So sine theta is equal to a over h. Also note that cosine of the complement of theta, which is 90 minus theta, okay, the cosine of this angle up here is going to be the adjacent, which is still a, over the hypotenuse, which is still h, and notice that now sine theta is equal to cosine of 90 minus theta. Likewise, if I wanted to do tan of theta right now would be a over b. Notice that cotan of theta, and I'm switching the colors here just so we can see, cotan of 90 minus theta, so here's 90 minus theta, is going to be b, cotan, so it's going to be the adjacent over the opposite, a over b. okay? And they are the same. So, to cut to the chase, here we go. Get these down in your notes. Stop the tape if you need to, but these are your 6 co-function identities. Okay, good. Now that you have those down in your notes, let's move on to our odd-even identities. There are 6 of these, and these for my level 1 kids are something that you need to know cold. The level 2 kids, you can kind of, I'm going to show them to you. They will come up in class, but they're not as important as the others. The thing to remember about these things, odd functions. Odd functions are such that when you plug in a positive number into x and something comes out, when you plug in the resulting number, the opposite of that number, the opposite result comes out. So f of x is equal to negative f of negative x. Even functions work the other way. When you plug in a number, x, when you plug in the opposite of x, notice that now the same results come out. Okay, they're both positive or whatever they are. The same results come out. What you need to keep in mind now is that in trig, sine and tangent are both odd, while cosine is going to be even, which means now if sine is odd, cosecant is odd, and if tan is odd, cotan is odd. Likewise, if cosine is even, then secant is also even. So, get these down into your notes. We have on the left side here, these are my odd identities. Sine theta is equal to neg sine neg theta. Notice that we have the negatives both inside and outside. Tan theta is equal to neg tan neg theta, etc. On the right side, these are my even identities. Notice that when you plug in theta or a negative theta, the same cosine still comes out. Okay? So my even identities are cosine theta is equal to cosine neg theta, and secant theta is equal to secant neg theta. Okay, let's do an example for 2 or 3. I have a little poem. When in doubt, draw a triangle. So I'm looking here right now, my tangent of x is positive. My cosecant of x is negative. So first I'm going to play the game. What quadrant am I in? Very good. I'm in the 3rd quadrant, so I'm going to draw a 3rd quadrant triangle. I'm hoping you all recognize this as my 3rd quadrant triangle. There's my reference angle. My theta is actually this thing going around in blue, correct? Okay. But any which way now, I'm going to go right to the cosecant. My cosecant is -2, so that's my hypotenuse over my opposite side is going to be 2 over neg 1. Okay, I recognize this as a 36,669. That's now neg root 3 because I'm in the 3rd quadrant. My sine is going to be -1 over 2. My cosine is neg root 3 over 2. My tan, they gave it to me, is root 3 over 3. My cosecant is the reciprocal, and they gave it to me, neg 2. Secant is going to be 2 over neg root 3, which then becomes, because I multiply by neg root 3 over neg root 3, which is 2 root 3 over 3, and the reciprocal of the tangent is going to be root 3 itself. Okay, so there is that one. Tan theta is undefined, sine theta is positive, so I know that my sine, my y, has got to be positive, and my tan theta is undefined, which means my cosine is 0. So I'm right on the y-axis. In fact, I'm on the positive y-axis. So if this is my my axes, and here is my unit circle, my ordered pair, or my point, is right here. Here is my theta. It's actually 90. Okay, but my ordered pair is 0, 1. So now I know my sine is my y, which is 1. My cosine is my x, which is 0. My tan is going to be 1 over 0, which is undefined. My cosecant is reciprocal of 1, which is 1. My secant is the reciprocal of 0, which is undefined. And my cotan is the reciprocal of undefined, or the reciprocal of 0, 1 over 0, which is 0 over 1, which of course is 0. Okay? There we go for that one. Alright, I'm going to do a couple of simplifications, and then we'll be done. The directions on this are to simplify. There is no rote way to do these things. We'll do a bunch in class. Okay, but as I look at this, I'm going to look at my tips. And the first thing that I'm going to want to do is I'm going to want to multiply by the conjugate of the bottom, okay, on both top and bottom. So I'm going to multiply by 1 plus sine, and you don't need to write the y if you don't need to, 1 plus sine, both top and bottom. Now when I distribute up top, I'm going to get cosine squared plus cosine squared sine all over 1 minus sine squared, 1 minus sine times 1 plus sine is 1 minus sine squared. When I FOIL it out, we know that those are differences of squares, and my middle terms will cancel. The beauty of this now is I have cosine squared on the bottom. If you remember from your Pythagorean identities, cosine squared is on the bottom. 1 minus sine squared is equal to cosine squared. And up top, I probably should not have even multiplied through, but I'm going to factor out the cosine squared up top, and I have cosine squared times 1 plus sine squared. Now you notice I can cancel, love that, cancel my pen. Cancel those cosine squares, and I'm left with 1 plus sine squared, and that's much simpler than what we started with. Let's try this one, and this will be the last one. We're going to FOIL this out and see what happens. We're going to try to verify the fact that this complicated side on the left is equal to the thing on the right. Looking at your tips, there's a couple of things that we can do, and again, we have a lot of tips. I'm going to start by FOILing, just see what happens, and then I'm probably going to write my cosecants, my secants, and my tans, etc. in terms of sine and cosine. Okay? So I'm going to start by FOILing. We'll do that in red. Secant times cosecant. So I have secant times cosecant plus secant minus tan cosecant minus tan is equal to cotan. Well, that didn't help me at all. I have no like terms whatsoever that I can combine. Pretty yucky. In fact, I made things worse. Let's see. Okay, I'm going to take my secant and my cosecant and my secant and my tan and everything else. I'm going to write these in terms of sine and cosine. Secant is 1 over cosine. Cosecant is 1 over sine plus 1 over cosine minus tan, of course, is sine over cosine times cosecant, which is 1 over sine, minus tan, which is sine over cosine, is equal to cotan, which is cosine over sine. Now, let's take some looking. Let's do some looking and see what I got. Not a lot. Let's get a common denominator. I have a term right here, one term, a second term, a third term right here, and a fourth term right here. Okay? I need to get a common denominator of sine, cosine on all my fractions. I have them already in this one. I already have it in this term. So what I'm going to do now is I'm going to multiply. I'm going to multiply this fraction by sine, both top and bottom, and this one by sine, both top and bottom. Okay? So that's now going to leave me on the bottom of all these fractions, cosine sine, and this still, of course, equals cotan, which is cosine over sine. So now I'm going to have 1 cosine sine, that was this term, plus sine over cosine sine, that was this term, minus sine, that's this term, minus sine squared, that was this term. All of those over cosine sine. Do we see now that plus sine minus sine, that's going to cancel out, and that leaves me with 1 minus sine squared over cosine times sine is still equal to my cotan, which is cosine over sine. Okay? 1 minus sine squared, we just did that problem, that's cosine squared. So I have cosine squared over cosine sine is equal to cosine over sine. I can cancel a cosine from both top and bottom here, so this goes and this goes. This leaves me with cosine over sine is equal to cosine over sine. I have verified my identity, and I am done.